Hi, my name is Hannah Lohman, and I'm a member of the QSDsan group that uses quantitative sustainable design for sanitation and resource recovery systems. The previous video covered the basics of SanUnits, so in this video, we will cover how to create a SanUnit subclass. Specifically, the tutorial we are working from is the SanUnit Advanced tutorial. And before we get started, let's import QSDsan. And we can also check what tutorial or what version we're working from for this tutorial. And so we can see that I am working from the version 0.3.5. So the first section we will look at is Python class creation 101. And specifically, let's look at the syntax and methods. And so to create a class, at the bare minimum, this is what you need to have. So this is the class we just made. The class name is I am a new class. And then at the bare minimum, you need to have class and pass. And so now that we have created this new class, we can create an instance of the class. And so here we are saying instance 1 equals I am a new class. And then we can look at the type of instance 1. And so here we can see that the type of instance 1 is our class, I'm a new class. And this is not really a very useful class because it doesn't do anything. So let's make a class a little bit more useful. And we can add data and functions to the class to make it a little more useful. So here we are creating I'm a useful class, and we can define the function do something to print thinking of what to do. And so let me add some lines, and now we will create an instance of I'm a useful class. And so here we have instance 2, and we can look at the type. And we can see that the type of instance 2 is the class I'm a useful class. And since we included a function to go with the class, let's use that function. And so we can have instance 2 dot, and then the function do something. And if we run this line, we can see that it printed thinking of what to do. And so the do something function, when it's associated with I'm a useful class, is called a method. So any function that is associated with the class will be a method. And so a method is written in this format. So you can define the function name and then have self in the parentheses, and then whatever code you want the method to be. And so there are different types of methods within a class. And so in this case, this was an instance method, which means it works on instances of the class, like instance 2. And the salient feature is that it requires self as a method argument. And so I will now go over 3 different types of methods within a class. And so this is the code. So I will copy it into our Jupyter notebook. And then I will talk about the different methods that we can work from. So first, I will look at this third method. And so this method is called I need self. And so specifically, this method is an instance method, which means this method belongs to the instance of the class, but not the entire class. And the instance method requires self as an argument when you define it. And so you can see that this method will print, I'm an instance method, I need self, and then it will print the name of the class. So let's go ahead and use this method and see what it can do. So I am a more useful class. And then I will say I need self. And we can see that it printed, I'm an instance method, I need self. The name of my class is I'm a more useful class. And so we have an instance of the class. So we had defined our instance as A, and then we were able to call this method. Now we'll look at a different type of method. And so the second line of code is called a class method. And so this means that it belongs to the entire class, not just an instance. So you don't need to create an instance of the class to be able to use this method. The class method requires the class as the argument. And so here, when we're defining the class method, you can see that we have class as an argument. And so now we will go ahead and see what this can do. So here we can say, I am a more useful class dot I need class. You can see that it printed, I'm a class method, I need class. The name of the class is I'm a more useful class. Then the next method we'll talk about is a static method. So this first method is a static method, and this means that it doesn't need to be associated with an instance or a class. So we do not need to provide an argument as a class or self when we're defining it. And then this is also a static method as an example. And so here we are requiring the object as an argument for the definition of the method. And so here I can show you how we're going to use this method. So, oops. I am a more useful class, and then a dot print class. So here we didn't put the argument in, so we need to make sure that we put an argument in. So we can put the argument A, and we can see that the class of this object is I'm a more useful class. So essentially the main difference in using these three types of methods is that for the class method, when defining the method, you need to provide class as an argument, but when using it, you don't need to. For the instance method, you need to include self as an argument when defining the method, but again, when using it, you don't need to. For the static method, you don't need to provide anything when you make the method, but when you use it, if the method requires any argument, such as the object in this last example, then you need to make sure that you provide the object. And so this section is going over the examples of how to use the different methods. And so now the next section we will talk about is the attributes and properties. So we talked about how we can add methods to a class, but what if we want the class to remember some data? So now we'll go through some examples using apples and their colors and the apple names as an example. Okay, so first, let's look at this example. And so here we are defining the class apple, and we are using the init method, which is a built-in method, and you call it when you initialize. So if you want to do an instance. And so here the init method is specifying that when you use the apple class, you have to provide an argument name, which here would be the name of the apple, and then the argument color, which would be the color of the apple. And so we're assigning these arguments as an attribute to the apple class. And so here we're assigning the attribute name as the argument name, and then assigning the argument color as the attribute color. And then we're also having this class introduce the apple. So we're using the method introduce, and when used, it will print my name is, and then it will have the apple name, my color is, and then the apple color. And so then here are some examples of using the class. So here we have the class, and then we're specifying the argument name, which is the Gala apple, the argument color, which is red. And then we did the same for Granny Smith and Pink Lady. And so now we'll be using the introduce method within the class, and we'll be introducing the Gala, Granny Smith, and Pink Lady apples. And so here we can see that it printed exactly what we expected. My name is Gala, my color is red, and then the same for Granny Smith and Pink Lady. And so again, with the init method, we will have the attribute name as the argument name. And so when we did that, we added the attribute called attribute name to self, and then we passed the value of the argument name to the attribute name. And so you can think of this as anything after the dot of a class or instance. And attributes can be data, method, and even modules. Similar to the instance, there is the class method, and so there are instance attributes and class attributes. And so let's look at this class example again. And so here we can see that within the init method, we have all of these instance attributes, the attribute name and color. But then outside of this init method, this is where we'll find the class attributes. So anytime you're using the apple class, we will have a class attribute as fruit. And so I'll point this out so we can see this. We see that there's apple after apple 2, and this means we're making apple 2 as a subclass of apple. So we don't have to define the introduce method. We can just do this because the apple class already has this introduce method, and so apple 2 is a subclass of apple. So here we can still use this method, this class method, introduce, with this subclass apple 2, and we can introduce the red delicious apple. And so we know that this method is coming from apple. Let's go ahead and print this just to make sure. We can see that the method is coming from apple, apple.introduce. And so the class attribute, there's a class attribute that is associated to the class and all of its instances. So here, remember that we defined the class attribute as fruit. And so if we do apple.class attribute, we should see that it is the fruit. And so here, we were able to say red delicious.class attribute is a fruit. And then again, apple2.class attribute is the fruit. And so another concept you might have heard of, property, and you might get confused about the difference between property and an attribute. And so you can think of a property as a special kind of attribute. Its specialty lies in the need for getter, setter, and deleter, functions to get values, set values, and delete values. And so here, now we will do a subclass apple 3, or a class apple 3. And so here we are defining the instance attributes, argument name and argument color. And then we are defining the introduce again to introduce the apple. And then here we're defining properties. And so this means that it's a decorator with the @ symbol. We have a link for more information about decorators if you're interested within this tutorial. And so here we're defining the attribute color, and we are using this underscore to show that it will be a property. And then we've also defined the attribute color with a setter function that would allow us to change this attribute underscore attribute color with the argument as color. And so we'll go ahead and run this. And we can see that it is writing, my name is Scarlett Gala, my color is scarlet. And so we can see that attribute color without the underscore is a property. Here, this is the property. With the underscore is the attribute. And so Python doesn't know the value of it before you create the instance, so you cannot get the actual value. So here we note that you'll get an error if you attempt to do the following because underscore attribute color is an instance attribute. So I'll go ahead and put this in just to show you. And so we get an error. So it's telling us that the object apple3 has no attribute underscore attribute color, because the property is actually the attribute color without the underscore. And so why would we want to use the property and add those extra lines? And so this allows us to use functions like getter functions, setter functions, the deleter, like I mentioned earlier. And so we can prevent users from accidentally changing values. So if there is an attribute that is inherent to the class and you don't want users to be able to change it, then you might want to use functions to prevent them from doing that. And so here I'll go ahead and add this new class apple4, just so we have that. So you can also add lines of code. So here we added trying to retrieve the value. And then again, it printed the apple name and the color. And so say we have a user that is trying to change the attribute color to green. And so here, they were successfully able to change the color of the Empire apple to green. But we know that the Empire apple is actually red, and it will never be green when it's ripe. And so we want to prevent users from being able to change an attribute. And so we can just take away that privilege by using setter. And so as an example, let's look at class apple5. Again, everything is the same, but here we're using the setter. So we're having them set the attribute color by using the underscore attribute color. And so here you can see that the apple is golden delicious and the color is the golden. And so if you were to try to change the color by potentially changing the apple to be green, okay, so if we remove the setter, which allows the user to change the value, and then we run it, then we'll see that we'll get an error because we cannot set the attribute because we removed the setter. And then finally, you can make it more helpful or hurtful by adding questions. And so I'll go ahead and copy this over. And so here, if we go ahead and run this, we can see that there is it is allowing us to change the color, and so we changed it to dark red. But if we go ahead and try to change it to red, then we'll get an attribute error saying that it will not let us change the color. And so you can add in these attribute errors as a way to help the user understand why they aren't able to do what they want to do with the code. Okay, so now we will go ahead and move on to the basic structure of SanUnit subclasses. So we were equipped with the basics on SanUnit in the previous tutorial and the syntax of creating Python classes. So now we can learn more specifics about creating subclasses of SanUnit. And so these are the fundamental methods that we'll be using for creating a SanUnit subclass. So in addition to the init method for initialization of all SanUnit objects, we have 4 fundamental methods, and they all will start with an underscore, as users typically won't interact with them. And so the first one is underscore setup, which will be called first among all of these methods to set up the unit. So you can set the influent phase. Underscore run is used for mass and energy calculation within a unit operation. For example, if you have an anaerobic reactor that will convert 80% of the organics in the influent, then you'll want to put it in underscore run. There's also a run method that will call the underscore run method with any specification functions that you define, but we'll skip that for now. Underscore design is this method. This method will be called after underscore run when you have a system with multiple units. Then underscore design will only be called after all the units within the system have converged. The underscore design method contains algorithms that are used within designing the unit, such as the volume, the dimensions, and the materials. Material inventories are calculated in underscore design and are usually stored in the design results dictionary of the unit, with keys being the names of the item and the values being the quantity of the item. All entries in the design results dictionary should have corresponding entries in the underscore units dictionary to provide units of measure to the values in the design results dictionary. Underscore cost is another method which will be called after underscore design to get the cost of the unit, and it may leverage the inventories calculated in underscore run or underscore design. Purchase cost of the inventory items are usually stored in the baseline purchase cost dictionary, and installed costs of this item will be calculated using different factors. For the bare module design, pressure, and material factors, they're all dictionaries. Only the bare module factor, F_BM, is mandatory. The others will be defaulted to 1 if not given. If you want to assume all material inventory items purchase costs equal installed costs, then you'll set this bare module factor to 1 when you initialize the subclass. So these methods are all aggregated into a simulate function that will call these methods and do some other minor stuff. And we will note that you do not need to use all of these methods, and you don't need to strictly follow the functionalities above. For example, you can put cost algorithms in underscore design or even underscore run, but the latter will be strongly discouraged unless you have a good reason, as the cost algorithms will be run a lot of times when the system is trying to converge, which adds unnecessary overheads. And then this section you can read on your own time has some useful attributes for the SanUnit subclass. And now we will do an example by making a simple aerobic reactor. And so with all of those descriptions, there are many details that would be best covered in an example. So let's assume we want to design a very simple aerobic reactor that will convert 90% of the influent organics into carbon dioxide and water. So this is the very simplest form of the aerobic reactor. And so here we have the class. And so here we want it to be one word with capitalized words. And so here we have aerobic reactor 1, and then the class will be the SanUnit. So aerobic reactor 1 is a subclass of the SanUnit class. And then this is the simplest form. So we have the init method, setup, run, design, and cost. And so then we want to load the default components as we learned in previous tutorials. So here we are using the default components, and we have compiled the default components that we will use for this aerobic reactor. And now we will make a fake waste stream that will be used for the aerobic reactor with these components. So here we are also setting these two components of the waste stream to be 1,000 and 0.5, specifying the units, and we can see our waste stream. So here we can see that our inputs are showing up in the waste stream, and we also have the concentration version. So now that we have the waste stream, we can have that waste stream be used for the aerobic reactor. So here now we have the aerobic reactor, and the influence is the waste stream that we just defined. And once we have that, we can sort of see something, but without the methods above, we aren't really doing anything useful. So let's try to implement those methods. So now I will copy the example into the code. We can talk about it. Okay, so here we have set up the init method, and we can add the conversions. We want the default conversion to be 0.9. We can add an aeration rate, which we are having as 5 grams per liter. And then we can also define the HRT. And so here are some standard code that you need to include for all subclasses of subunits or SanUnits. And then these are some unique attributes of the aerobic reactor. So we have what we defined above. We are going to have the conversion, the aeration rate, and then the HRT. So you can add any attributes that make sense for the SanUnit that you're developing. And then we're also going to have the bare module factor as 2 for when we're doing the costs. We'll also have our influence, the waste stream, and the oxygen, as well as 2 effluents, the treated waste stream and the generated CO2. And so here we are specifying that we have 2 influents and 2 effluents. We will want the carbon dioxide and oxygen streams in the gas phase. So here we're adding this line to use the setup method, and including it in the run method will be the same. So here we're specifying that the influence and the effluents will be in the gas phase for the oxygen and the carbon dioxide. Now we have the run method, where we will run the mass and energy balances. And so here we have the influent and effluents. And then here we're specifying how much oxygen we need. So we have an aeration rate, and then we have the volumetric flow for the influence. And then we have how much oxygen is turning into dissolved oxygen. And then we're able to determine what the effluent values will be. Then we also want to use the units method to specify what units we're working in. And so for the reactor volume, we're in meters cubed. The diameter and height will both be in meters. And then the stainless steel required will be in kilograms. And then we can use the design method to actually design the reactor. And so here we're able to design the volume, the diameter, and the height. And then we also are calculating how much stainless steel we'll need. And so this is the volume we need of the stainless steel, and then we're able to use the density of stainless steel to calculate the mass of stainless steel we need. And then we can use the cost method to calculate any costs associated with the SanUnit you're developing. And so here we're going to calculate the costs of the tank, and we're able to use the stainless steel requirements to understand how much a tank would cost. And then you can also include electricity as a cost within the cost method. And then with the property, you can set up a conversion property. And yeah, that is an example of using the SanUnit for an aerobic reactor. We can go ahead and run this. And we can set up the unit. And then we can go ahead and simulate it and see our results. And so here we are able to see how much power we'll be needing for the system, the electricity power, what our specific design is that we are interested in, how much stainless steel we need, and then purchase costs. So this is a very simplified version of an aerobic reactor, and it just shows how you can use the SanUnit as a way to model different systems for a sanitation wastewater treatment plant. And so then in section 4, we have other convenient features. So I won't go into this with too much detail, but you're able to simplify the chemistry, the chemical reactions by using thermosteam. So definitely go ahead and look into thermosteam as a way to simplify these many lines of code into just using the reaction from thermosteam. And then you can just simplify it to one line of code by using the reaction instead of manually changing the input and output values. So this will be the end of this tutorial, and I hope you found it very helpful, and I would encourage you to take advantage of going through these tutorials and getting more familiar with the documentation in QSDsan.